Hi, I'm Kyle. I've been in games for 15 years-ish now, maybe actually going on a little bit longer. Currently, I am an engineering manager actually at Unity. I work on Core CLR, so I'm the guy doing all like the net transition work. That's on my team. Prior to that, I worked at a company called Possibility Space, which is like a AAA game development studio. I also before that was working on my own indie game that shipped called Cantata, which is this large scale tactical strategy game. And then kind of along the same time, I've been doing like a lot of tooling and tools related work. So I have like found myself in general in my career drawn to creative tooling for like kind of like technical oriented people. So I'm gonna actually find it. At one point, I was actually getting frustrated with Unity. And kind of how it treated 2D. And I wrote this blog post forever ago. This is you can obviously able to find on the internet. I have I have no Google doppelgangers. It's just me. Yeah, February 25th, 2021. So a little over 5 years ago, I said, I guess I'm making a game engine. I was kind of in the midst of making Cantata at this point. This is actually still, I think, pretty relevant to what I'm doing with Zinc. But I was in the middle of making Cantata with Unity, which I still, I use it. I love it. I work there now. But I kind of felt like at the time there was a better way to potentially like make something with 2D, especially in C Sharp. At the time, .NET 5, which was the first cross-platform .NET release, had come out, I think in like 20 on cross-platform desktops. You could do anything. So you could just run it on any desktop platform with Core CLR. And I was kind of looking at that being like, I feel like there's a way to do this that's not like a huge engine, right? So I kind of like started just going down that path. I was not at that point like very platform oriented. I hadn't done a lot of lower level programming work. So it was a bit of jumping off the deep end and a few false starts, but it's still kind of plucking along in the background. Sorry, I want to quickly do a time check. I'm giving you a lot of prehistory. I don't know how much time I have to actually speak. If someone can tell me how long I have.
So the meetup itself ends at 11:30. Take whatever time you need.
Okay. So if anyone has any questions along the way, I get there's chat here. I don't know how to find the chat. Here we go. Start chat. All right, great. So if anybody has any questions, feel free to, poke them up as they come up. I'll try to read the chat. So anyways, that's a lot of like prehistory to say, like at the time in 2021, I felt like there's a better way to make 2D games using C Sharp. And that's kind of where this idea starts. From there, I like do a few different things. I work with a few different like platform abstraction libraries. A year or so ago, I think it was Noel Berry. This is one of the guys that worked on Celeste. He wrote this post last year called Making a Video Game in 2025 Without an Engine. This is basically like all the work that I sort of did along the way that he nicely has since captured in like a blog post. So a lot of the same stuff still applies. I had to kind of discover it myself, but the TLDR is that it's a lot easier than you might think now to make your own engine. So I don't know, try it if you want to. I'll take a small step back to just describe. I'll start talking more about Zinc specifically. So, where is it? Yeah, here we go. So when I started with Zinc, I kind of have like three main like pillars. So Zinc is primarily a 2D engine. I'm not trying to do 3D at all. So if you want to do 3D, Zinc is not for you. But taking that as a constraint, I was like, well, I can actually add on things to this engine that are like more like philosophical goals for how I want to work as a programmer, instead of just like trying to make it have really cool graphics or whatever. So the three kind of pillars which matter for what I'll talk about in a little bit are immediacy. So like I want everything just to kind of like happen. Like the code itself should feel kind of immediate in terms of what it allows you to do. So trying to get rid of abstraction where possible. Coziness. This was like pre kind of anti-cozy work, but I think that I wanted things to be able to kind of feel like compact and you could like hold them in your mind, right? Something that's like not cozy is like a sprawling abstract hierarchy of classes, but something that like maybe defines functionality for something like in one place is kind of cozy. And then also I have magic. So this is a lot of this was like a bit of a reaction to Unity at the time, where I felt like you can't do stuff like this in Unity. This might be really small, bigger. You can't just like create new objects that are like things. You have to kind of go through this process of like asset importing and all this work. That's like fine for what Unity does, but for me specifically, I wanted something that felt like I could just kind of like author stuff and not have to worry about like, I don't want to have to worry about the whole architecture of my game at the point of like authoring it. I want to be able to kind of like slap stuff together pretty quickly and let it scale to something bigger. So immediacy, coziness, and magic. So these are like my kind of my core pillars of working on Zinc. And yeah, I'll take a quick break there to see if there's any questions before I kind of keep going. Sometimes I can make the window full screen. I can't, but the text is the same size. Move this over here. Someone's typing. Okay, someone's not typing anymore. All right, I'll keep going. So that was kind of the start. I won't get too much in the architecture of the engine itself, besides to say that I ended up choosing Sokol for this. Sokol is a library written in C that is a cross-platform framework. So I'm not doing any of the like shader wrangling stuff that Sokol does. So this provides you like the ability to open a window, the ability to like draw stuff, a lot of that. I'm also using Sokol GP, which is like basically a simple API on top of Sokol. So Sokol itself is built for like general purpose 3D work. I am using Sokol GP, which basically adds like a pipeline on top of Sokol to make it more 2D oriented. So that's all I'll say about architecture, unless someone else wants to talk about it. I'll launch the demo. I'll launch the engine now, and then we can start looking at some code, assuming that's what people want to see. So just as like a demo of functionality here, I'm going to, where's that? Here? Nope. Here. So for Zinc specifically, there is, let me close this. There's this repo here called zinc.demos. So if you go to GitHub, there's Zinc Framework is the kind of like the organization where a lot of this stuff lives under. There are repos here that kind of do everything. The main ones are like Zinc, obviously the engine itself, and zinc.template, which we'll look at in a second, and then zinc.demos. So these are kind of the main ones. These are also pinned up here, Zinc, template, and demos. So if I clone and run the demos, you'll see this. One thing to note here too is like it's all driven by like Core CLR. So Core CLR is used as the runtime for Zinc. So all of the code itself flows into Core CLR, and that flows into like all the kind of like wrangling around like p invoke stuff into native code. But again, I won't get too much into that unless you care about that. So here's Zinc. This right here is working. There's a square on screen. Great. We can draw a texture. In the demos repo, the way I sort of like worked on Zinc was that I took a thing I wanted to do, and then I would make a demo out of it as kind of like an example. So the demos themselves are split up into scenes. If you've not used like, no, I won't talk about that. There's scenes, like kind of like Unity or Godot or Unreal. Each of these corresponds to a folder inside the demo repo. So if you go to demos here, you can see all the names of the scenes that work. So for this one, I'm at texture. Texture is right here. So this is like basically what it takes to render a texture on screen. It's a little bit more than that. I'll pull up, I guess I can just pull up the actual code here. Whoa, 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 whoa. So this is the texture code. There's some more stuff going on here for like basically switching between scenes, but the idea is that like you really don't need to do a lot here. I'll actually even I'll show that in a second. I guess the thing to show is that like all the engine is open source too, so it's not like behind any sort of gate or anything. You can download it and work. So when you download the demos repo or you download the template, which I'll show in a second, you get all the engine source as well. So if I want to see how like any of this stuff works, like if I go to the texture demo and I want to look at like I don't know, scene, right? Here's like the source code for scene and the Zinc engine. There's no like, it's not obfuscated anyway. And you could change it if you want to. So this is a texture that's very simple. This is a texture frame. So the point of this is that this is actually an image from a sprite sheet, and the sprite itself is sliced up. So this was like one of the first ideas I had when I like had Zinc, which was I found like Unity's way of doing 2D asset importing like very frustrating. You have to like import the texture, you have to do all the stuff with the asset importer, and you have to slice it. You have to use their little like UI stuff, which can be fine for like certain kinds of games. But I was like, this is very hard to do if I want to just like slice up a texture. So like this is all you have to do here for Zinc. So what I'm doing here is I have this texture I load in, and then I have some sprite data. And what I'm doing is I'm literally just like slicing it here in one line of text. I have that here. And then in create, I'm making a sprite that has that image inside of it. So it's like sort of like 2 lines of code to do that. It'd be just as easy to do like any other part of the sprite sheet. But for time, I'm not gonna go into every part of the API. One thing I will show here is this. So I'll also bring up the concept of like magic. So with Zinc, I at the time was like really getting into the idea of like source generators. So I don't know if anybody who's like on this call knows C# knows about source generators, but it's basically like a way to generate code as part of the normal compilation pipeline that it's sort of like a replacement for reflection, but also it allows you to like kind of respond to other things as part of the compilation process and have that be like IDE accessible. So here's a really good example. So res.assets.conscript, right? Like this is not part of the Zinc like API. What it gives you is like a type safe access to like an asset. So if I did res.assets.this, right? This is actually the logo in here. I'll make a really quick illustrative example here. What's this called? Big. I did big. And then I'm going to find where this conscript is at, because I actually don't know off the top of my head. Res, here we go. So if I open up this folder, where's that? Open folder, open, find, open, what? Why can't I find open? Is there no open? Am I crazy? Oh, reveal in File Explorer, excuse me. Okay, so I'm going to take this, I'm going to save this as a PNG. I'm going to put it here in my res folder. This is a special folder for Zinc, and we'll call it big, okay? I'm saving that there. It's now in this folder, right? Great. If I come here now, let's see if this works. Big, okay, great. And we'll slice it. I don't remember how big this was. How big was it? 7. Well, that's an annoying number. Let's just do 500 by 500. Okay. And then I'm going to, I do have to restart this. I do support hot reload, which that's a separate conversation, but so I'll load this. And yeah, I mean the slice is off, but hopefully you get the point here. So like there was no asset importing that had to happen. And not only that, but when I put an asset in my project, Zinc basically like generates this for you. So any asset that you put inside that directory is an addressable in code. What that also means is that this happens. So let's imagine I actually delete this asset, right? A lot of us have deleted assets on accident before. And I save this. And let's just try to run this again. What do we think is going to happen? I have an error because I don't actually have big here. So like my asset issues actually become compile time problems. So if an asset gets moved away or something, I'm actually going to throw an error here, right? Like this is going to appear in my IDE. So if this happens and like you're collaborating with someone or someone pushes code, right, and they like delete an asset on accident, like it's going to turn into a compile error. It's not like a runtime pink texture thing. It just literally won't compile. I think this is like huge. So this has been super helpful with just working on stuff because it also means you can iterate really quickly. There's like a single source of provenance for kind of like anything that gets put in a directory. So yeah, so this is coming in here. I'm going to put this back to the thing that isn't here, conscript. Okay. Awesome. I'll run this again. What else do I have? Animation. So animation works. This similarly is one of these things. It's kind of hard to see because this is a little small. This is another thing that I want it to be really easy. So if I look at the demo here, somewhat similar. Basically, I create some slices that are of recs. So this is creating like effectively like a 512 by 512 texture of 64 by 64 blocks. And then I make animated sprite data here by passing this to the sprite data. So this is basically saying, given this asset, and again, I could use big here, create these animations. There's an animation called North that uses recs 1 through, or index 0 through 3. This is the speed of the animation. So this is like 4 separate animations, all authored in single lines of code. I then create the sprite with the animation data. I have coroutines, which are nice to have. Obviously, if you use Unity or something, you'll know that. And then I'm just basically iterating through here. And I'm just setting the animations here. So pretty easy, especially, again, if you're coming from like a Unity or something. It's a lot harder to do than something like this. The idea of this, again, is like immediacy, coziness, magic. Like it's just happening here. You want to see how the animation is created, it's here. I'm doing this work inside of a scene. You could do it like elsewhere in the code. So we have animations. We have updating. So this is actually something I'm going to show slightly differently here. So I'm going to say .NET, watch this. So Core CLR by default has like a hot reload functionality, and this is like major, especially for game development. So I'm gonna go to simple update here. So this is a basic update loop where I'm just moving the sprite back and forth. We'll look at the code here. I load my sprite in, and then I'm basically creating a position, and this is, yeah, I'm passing an update function, which I'll talk about in a second. But the key here is that I'm just basically changing the direction back and forth, right? I am in hot reload right now. So what this means is like if you've never worked in like a hot reload context before, basically it's different ways to do this based on like what you're running. But for Core CLR, it supports it by default with this thing called .NET Watch. So because Zinc runs on Core CLR, it can just leverage this basically without me having to do anything. So an example here is that there's this Lambda passed in as an update function. I'm going to change, so we can look at our conscript here. So he's going back and forth. Great. I believe this should work. If it doesn't, I have an idea about why. I'll save this. And then now it's much bigger, right? Let's maybe make it like even bigger so it's not so crazy, right? Look, I didn't have to recompile. I didn't have to close it. I didn't have to open it again. It just works. So you can do this with like, there are some limitations to hot reloaded Core CLR. Like if you change like the parameters of a method or something, It'll want to recompile, but usually if you're working in kind of like an immediate mode context or an update loop or something, or you're like changing arithmetic, you can get it to like work. If you do change something that like forces the hot reload to not work, it'll just do like a normal compile. But you can imagine like doing stuff like this is really nice because like if I want to tweak a value, instead of having to like build an editor here or something, I can just like do it in the code directly. That said, these things are possible. So let me actually just go here. This is not going to work actually, but let's see. This said it works like I want it to. I'm not going to do that right now. There are other examples later. But anyways, update loops work. I also want to focus on this. So again, like with the idea of immediacy, the idea of Zinc is that like ideally you can like author everything at the point of declaration. You don't have to do that. You can like create classes and stuff to like wrap some of like the core primitives of the engine. But every sort of like core entity that Zinc exposes gives you usually two things. One is that you can pass an update loop to that entity, and you can also pass in children. So what this means is that like at the point of declaration for anything that you do like this, so this is slightly obfuscated because it's smaller, right? So this is my conscript. There's its frame, and then I'm actually giving it its own update loop here. Oops. Right. So I'm creating I'm like creating an object. I'm giving it what it looks like, and then I'm like literally telling it here what to do. So like an example of what to do with this is like imagine you have some platformer game, right? And you want to have like a platform. You want that platform to move like back and forth. You don't have to like make a class for platform and then have to like give it some functionality and attach that to something. You can literally just do it here. So you could just say move left and right. And that like basically captures it. It's not spread out anywhere else. Again, you can spread it out. You can make your own class and whatever. But I find that for really simple things, it's really nice to do this because if I want to figure out like, where's my conscript moving or where's my platform moving, I look here and all the logic for the whole object exists right here. You don't have to break it out. So I think that's like really nice. Keep going through some demos. We have interaction. So this is just basically me moving with like the keyboard keys. So input works, touch input, all that stuff works. What else do we have? This is like a bunny mark. This is like a performance benchmark test. You can see up here, this is like 10,000 entities. I'm running basically at 60 frames a second. So it's fast, I guess. Like if you have a lot of stuff that you want to run at it, and this is not even like optimizing. This isn't like optimizing to make this fast. This is actually literally creating 10,000 entities in the engine. There are faster ways to do what I'm doing here, but this is like the baseline. It's still pretty good. I can even spawn more. So that's 20,000, and it's a little slower. But again, 20,000 things in your game, probably okay. Shape. This is just there are ways to have like basic primitives that are shapes. The other thing Zinc does is that Dear I'm GUI is in it by default. So I believe we're still in hot reload here. So if I go to shape here, you can see, oh, wrong one. Shape demo. This is how you make a Dear I'm GUI window. So I have my window here. I set some rotation values. I'm setting some sliders, and then I'm assigning them to the shape itself. I could, just as easily add some other slider float here called, well, I don't know, scale Y. Oh, because Y is not in there? Okay, fine. I'll save that, come back here, and then now it's here, right? There's no like, this is a hot reload thing, right? So like, it's really nice when you start using hot reload and then start using things that work in kind of like a hot reload context. So like, I just added this item here and I can now control my object without having to like do any like additional plumbing, right? It just works, which is super nice. What else we got here? Physics. So our physics. This is all using what is? I just forgot what it's called. Box 2D. It's I don't remember actually. If I just updated to the new like Box 2D 3 with like some of the new header stuff, but physics works, which is nice. The code for this is like a little wonky right now. I'll say I got to make it be a little bit better, but in general, I would just say that physics works. This is, oops, I think I'm going to crash. Yeah. That's on me. Yeah, it's a recompile. So go back to, yeah. I guess this isn't really a demo besides just to be like, it's fun to emit stuff. Because it's also your engine or my own engine, you can do fun things like stopping the clear, which I can see. Yeah. So if you don't like clear the graphics buffer, you can just do fun, weird stuff like that. What else we got here? Collision. Yeah. So collision works. This is a pain in the ass. So you're welcome. So this is like, you can see here, the green dots, it's kind of small. The green dots show you, the orange dots show you the closest point to the surface from the mouse. And then also you can see that I can mouse into stuff and have it highlight. These are things that are like scaling with themselves. And so, if I keep my mouse here, the collision works across scaling and multiplying everything, which is great. Again, the source for this is all on GitHub. So if you want to see how these things work, I try to make it so that the code itself to do this is like relatively idiomatic Zinc. It's not like weird stuff. And if it is ever weird, I consider that on me to basically make the API better. So for like a collider here, I'm making a shape and I'm rotating it. And then again, like immediacy, right? So I'm jumping around a lot. There's a lot to talk about. And this is one of the first times I've like talked about Zinc publicly. So I appreciate you guys bearing with me. This is a whole separate side topic that's like its own talk in general. But the way Zinc works is it's an entity component system, which if you don't know what that means, it's fine. But the thing to know about it is that all the entities themselves, there's no editor, right? It's just code. But you can do like entity composition in code, again, with source generators. So the way that works is through like attributes. So because shape is tagged with this collider component, what that does is that if I look at shape dot, can I find it? It's shape.g. If I go here, I'll find it. Oops. So when I tag a shape, this is like in the engine, and you can also do this with, you make your own entities with your own components. Because I've tagged this with collider, this is a partial class. So what happens when the game compiles is that it actually emits the values of a collider itself onto the object. So all these like events that I have that are part of the collider itself get emitted directly onto the object. So this happens. It's a good one. Was it collision? What's it called? Start? Yeah, collider on start, right? So because I've tagged this here with this as part of its am I crazy? Oh yeah, it's the stuff. So because this is here, what happens is that it's basically like the engine takes that stuff and puts it on the object itself. So like, but what it does, it doesn't actually like move the fields themselves. It does this where it uses the actual ECS system to point to the internal collider of that object. So it's basically like it shims those actual accessors. All that to say, it gives you this really cool thing, which is that if I go to shape here, I now have access to all these like things that are part of the components, but are not literally declared on shape itself, which is like, I don't know, I think it's like sort of novel. And then because it's on here, you can then tie into that functionality at the point of declaration here. So if I go back to my collision demo, I have access to these events. If I was to actually go here and remove, I'm gonna stop hot reload. If I go to shape and like, let's say I remove the collider event, or sorry, the collider component, and I try to build, um, you'll see that I'll get like errors on shape because now all these things that I like, I'm basically getting from my collider component don't actually exist. So by adding like by using component through attributes, it actually puts the component fields on the shape. So you don't have to again like reach in and be like get component, collider, and then whatever. It's just on that object. So I'm gonna add that back there. Let's recompile so it works. And so here, just going back to my collider code, because this is all here, I get this kind of easy completion. It's not going to give it to me now because I'm saying it. Okay, well, fine. But anyways, I can access all my component stuff just at the point of declaration. So again, I'm not even using a class. This is just a shape, right? I didn't make like collidable object class or something. So that's all here. Go through some more demos. So we have collision, we have physics. Oh, we have grid. This is very much a 2D thing. There's just a primitive entity type called grid that allows you to put stuff in like a grid. A lot of engines don't do this. I thought it's like for 2D, it makes a lot of sense that basically you just have an object that is a grid that holds stuff, and you can adjust how the child objects of that grid are affected by movement of the grid. But the demo itself is relatively simple. You just make a grid, and then here I'm adding children to the grid. And then as I move the grid, all the children themselves rotate and scale appropriately. There's particles. So this is this is my particle demo here. I would not say this is like the most amazing particle system in the world, but it definitely works. So it's like, here's my particle emitter. Maybe I can make the lifespan a little bigger. This might not come through in the video, but there's like some pretty basic, just like particle math happening behind here. So you can mess with it if you want to. You can change the type. Emission rate. Yeah, whatever. It's a particle system. You can spawn it. If you look at the code, see how it works. Grid particle system. Asteroids is just a game. This is like a very simple. I'm just using the conscript sprite, but I can move this around and I can spawn with space and it will collide with this stuff. So it's a very simple, like if you want to make a game with Zinc and you want to try something simple, this is like a good entry point. Oh, sorry, a question. Curious if grid object would work as a nice bare bones starting point to make your own tile map system. 100%. Yes. Coroutines. Yeah. So you can see there's coroutines here. What this is doing is I tried to make these actually sort of similar to Unity, just for like, because I know people who are going to use this are going to have a lot of experience with Unity. So it's sort of similar, but you have a little bit more control. So I have this basically coroutine. I use an IEnumerator, which says find your next position, create a little shape there, and then move there. This is my move. I yield return these tweens here, and then it moves between the two places. Coroutines themselves can be stopped and started. So like I'll just pause this guy midway. So I pause it, it doesn't move. I can resume it. I can even reset midway. You can dive into this. I'm not super excited about some of the structures of the coroutine API. Like, I think it could be a little bit better. But for now, this is what it is, and it's pretty good. So fine. This is, you can ignore the cards demo. Children, This is also like a huge pain. Turns out there's a lot of ways to do like children hierarchies in game engines. I again took a system that I thought was like sort of similar to what people would expect, even if it's not technically correct. And what I mean by that is like, it's the proper way to do this is that like children inherit scale of parents and kind of apply additively. Instead, like if you scale an X of a hierarchy, like if you scale this object will also scale up. But the thing to note here is that these things can so all of like they can independently rotate, but changing some parent also changes the children under it. So this is like default functionality that turns out to be very hard to implement. Which if you made games, is just the case with everything. That players want stuff that they think is really easy. It ends up taking you a month. So similar here. There's text. This API right now for Zinc is like totally garbage. It is not fun to use, and it's like can be way worse.
Can I ask a question about the hierarchy that you just showed?
Yeah.
So you said you're running an ECS for those entities.
Yeah.
I've in making an ECS, I've made sort of child hierarchies by having sort of components that are indexes to trees and that have a transform relative to their parent. How are you implementing this? I found that to be quite cumbersome the way I was trying to do it.
I basically pre-compute the world position of every entity based on its relationship to the parent. So all XY positions of entities are local. So if you set an XY of something, this is not it's not a world position. You can like set world position. So I haven't actually so we did shape.
So I could less think about the position and more about the tree hierarchy.
Well, that's kind of what, so that's
know who their parents are.
Yeah, that's kind of so the hierarchy itself is. I'll just show you. So I got a shape here and scene entity and an anchor. This is kind of like the class. There's a parent pointer and then a list of children.
That's good. I appreciate that. Thanks.
Yeah. Basically, there's a parent and there's a children pointer, and then it kind of gets like unrolled in the actual system. So if you go to, actually know what it's called off the top of my head.
So what I think I heard is that all your positions are basically local. It's just anyone who doesn't have a parent is local to like the origin.
Local to the scene. So actually, well, it depends. So yeah, there's an origin and then there's a scene, and so but yes, effectively, yeah. If there's no parent, it's local to the origin. But most things have parents because they derive from scene object. But you can throw like raw anchors there, in which case they'll be local to the origin. But most things extend scene object, which implicitly is like stuff that's like in a scene. So yeah, basically, it's in the system itself. It'll like trace up based off like world positions of parents, or it'll get a world position by deriving it from the parent positions. Yeah. Turns out this is like super hard. So the fact you sounds like you've run into this before. It's like
it is very annoying.
It's surprisingly difficult, and there's actually like not a real answer for any of it. It's frustrating. Yeah.
I would just say that everything else that smelled like a component system that I ever made after that explicitly did not have hierarchies or children.
Yeah, it was honestly like so an interesting thing about this engine is that like I would say about 85% of it was me coding it, and then that was all pre-AI, and then as AI has happened, I've like used it sort of like I've vibe coded a lot of stuff before, but the engine I've treated it both as like a way for me to learn stuff, but then also like I do want to ship stuff with it. I did throw AI at the transform hierarchy stuff because I was like, I cannot figure this out. Like, I don't know what's going on. And finally, it basically solved it how I wanted it to be solved. So the API worked, and I was like, this looks good.
But it's annoying. I want to stop thinking about it.
Yeah, exactly. I want to just find real quick because it is sort of useful. And is it render system? I think it might actually be here. Is this it? Yeah.
We'll want to save some time. I'm sure a lot of people have questions at the end.
Okay. Yeah.
But I am interested in hearing a bit about the text rendering.
Yes. So this is it's just font stash. So this is actually this is like one thing that I benefit from is that anything that Sokol does, I can basically do. So Sokol, like I said, is my platform library. So if I go to, where's my like active window? This guy. Bum. So like these are all the Sokol demos. So like theoretically Zinc can do any of this because I'm using Sokol, right? If I look for their font stash demo down here, right? Looks kind of similar. This is the way Sokol works. It's basically opt-in headers. So I can just take the header and attach it and then effectively make it work. I had to do some like other stuff. Like I use STB true, I think I use STB true type to like load in the font, and I have to do some of my own like asset loading. But as long as I get the right pointers to those assets under the hood, I can then just pipe it to this. And that like basically works. Again, like right now, the API for this is not great. Let me see. I think I have to do like, I guess it's not so bad. You just create some text. Oh yeah, this sucks. Yeah, you have to like point to the font. So I want to add this stuff into that like the type completion res directory stuff. So any font just gets siphoned up here. And then you get like a type safe version of the font. The system itself is, yeah, I don't remember. Yeah, there you go. Move to resources. So yeah, so basically it's using Sokol's font stash implementation under the hood. I had to do some things around like text loading. I think it's actually like very ugly. Was it core? Yeah, this is like where the engine started. It's this like giant C# file, but so yeah, so this font stash header, it comes from Sokol, and this is basically just p invoke calls into the native library here. And so like unsafe C# actually mimics a lot of how semantics of C work. So by basically looking at the Sokol demo for how he uses the font stash API, I can like map that pretty directly to calls in C#, and it sort of works, which is great. Yeah, so this is all stuff that I ended up doing in the back end. Core, this file is like, I don't know, I wouldn't say it's embarrassing, but it's quite something. I need to like modularize it and take it out. But right now it works. It works. It's cool. Other stuff, and I can maybe talk about questions. Was there anything else here? I do support custom shaders. This was actually like an AI thing because I got really close and I was like, all right, you do it. So the way that like Sokol works generally is that they're like pipelines. So it's like you basically create like a graphics pipeline. It's got some number of like bindings for shaders and all that stuff. Sokol GP has a pipeline that's like by default meant to be just good for 2D stuff. Most of that just works. But to do like custom shaders, you have to basically make your own pipeline. So what this does is it makes a pipeline for a shader itself and then runs that shader. So this is like an SDF weird shader. There is also a cross compiler called SHDC that, what is this? I think it's called SDF. Let me find it. Oops. Yeah, so this isn't here. Anything that goes into res is a shader. It uses this like SHDC compatible GLSL code. So by tagging this stuff, SHDC is hooked up into Zinc as part of the compilation pipeline. So when you run, you just get this. What this will do is it'll basically cross-compile your shader for your target platform. So we're saying right now, Sokol works like on Mac, Windows, and actually does work on web. It's hard to get working on web, but it does work on web. So it'll compile for any of those targets. And then it will put them into, I think it puts them in here. Yeah, shaders. Yeah, so it'll actually generate the, oops, I just lost it. It'll generate the GLSO code or HLSO here. And it'll load these based on the resources for shaders. So if I go to like, yeah, so this is all the like basically invoking the shader stuff. Yeah, here you go. This is a Sokol specific thing, the cross compile shaders. So that's all hooked up in here. Any other last stuff before I take some questions? I'll point to so my repo itself, I actually have some like things in here. I don't know if I clone these. I don't know. I was trying to do like a creative coding thing in January called Genuary. That's sort of fun. And so I've been using it as a way to kind of like push forward Zinc. And how do I find my repos? So this. So some of this is like other ways of just using Zinc. So I was using it more for like creative coding stuff. I'll clone this down and start running it. I'll take some questions now though, while I get this running. People have them.
Yeah, questions, folks? So how are there any caveats, or how hard is it to make a web deployment?
It's a pain in the ass. And that's like that's not because of like Zinc necessarily. It's basically like I wrote, so there's two things. If you want to do this, I wrote this down both for like my own sanity and because it was really hard and I felt pretty proud of it. This post on my blog. So you want to compile your C# game engine to the web with Wasm. Basically, like you need to. The hard part about it is that there's a lot of just toolchain stuff to do this with C# that is like independent of Zinc. So you have to like download these specific C# workloads. You need to download a specific version of Emscripten. You need to like set some properties in your projects file. This is like pretty clear. I mean, if I remember correctly, like this is a good overview of like the what and the why of everything. And I do believe that the demos themselves, let me check. I should just compile them and host them. Be nice, wouldn't it? Yeah, so there is some notes about web here, about installing all the stuff you need to do, where to get native AOT LLVM, which is what you use, and then you need to use these specific fields, or sorry, command line arguments to run. And then I believe there in here is this is the web CS project file. So it's got some of the stuff that you need for this to work. So it does work. I haven't like shipped a lot of it. I bet if you took like Claude or something and threw it at my blog post in this repo, it'd probably figure it out and tell you what you need to do. Because I wrote this to be a reference for myself. And sorry, I really turn my video off. I wrote this to be like a reference for myself in the future for like how to do it. So it should be pretty good. Sorry,
yeah, the reason why I ask is it seems like Zinc would be just awesome for a quick iteration in a game jam. So, especially for programmers, but even for artists, just giving them some directories or folders to drop stuff into is probably a lot easier than having to go through the manual import process in an engine like Unity. So, when Ludum Dare comes around in the fall, I'm definitely going to give Zinc a try. Probably for Ludum Dare in the fall, just because Zinc seems like a great framework for really quick iteration.
Yes, I agree with that. There's other stuff that it does, like I don't remember if I used it in this project here. Let me see. I think I might have added it. Actually, I just cloned this. Let me open it. So like one thing you can do for Zinc that is like, it's like so hacky, but it's actually quite nice, is this. Let me see. I believe I did it. Oops. Yeah, tag. Yeah. Okay. So actually, I'm gonna run this real quick because it is pretty.
While that compiles, I have another question.
Yeah.
Is there anything for audio?
That's a great question. There is not, but it's only because I've not done it yet. It's like Sokol supports audio. I think Jeremy actually for his project he'd built even like got like a very simple audio system in. There's not yet audio. If you're doing it for Ludum Dare, I will try to get it done for you by then. I'd happily do that.
Okay, I mean, or I could try to just, use Sokol directly.
Yeah, or I mean, like AI could also figure it out too. Oh, sorry, I don't need to do. An interest modules, everybody. That'll make it work. I was talking about tags. So while this is cloning, so like to the point of like fast iteration stuff, like there's basically like levels of granularity in Zinc, right? The top level of abstraction is have a class for an object, and there's like references, and there's a class, and there's like something inside of it you can hold. But I tried to provide like enough kind of like UX DX type work that you can like just work with entities without having to think about classes a lot. One of the things I do here is this kind of like goblin mode tag system. So in Zinc, there's the ability to make tags. So if I look at like, where's it at? Yeah. So this is how you make a tag. It's just a record. So I'm calling this grid position, and then it extends tag, which is this Zinc thing. A tag is basically like a way to just store typed data on an entity. So entities can have some number of tags. Makes sense, right? But what you can do here is that you can actually start to use tags as if they're like ad hoc variables. So you can sort of store data in them. So like one thing I do here is that I'm actually like setting these like grid position tags, and then I'm like getting that tag here and then assigning different values to it and then removing the tag. You don't need to worry about with like the creative coding part of this, but the idea is that like I'm like sort of being kind of like obstinate. Like basically like I don't want to have to go make an object that represents like a grid position thing. I'm like, I'm going to use a shape with a tag and throw them on and off, right? And then what's sort of nice is that if I don't like that, I don't need to go and like update like some class to get rid of the tag. I don't have to commit to it. If I want to get rid of it, I just like get rid of the tag system, whatever. I think this is done now. Yeah, okay, here we go. So this is like more me trying to be creative with Zinc. It's not going to work right now because these are old. These are old AF, I think is the reason it's not going to work. All right, well, we tried. Anyways, these are like fun, simple, cool demos of making stuff work in Zinc. I have also made games with it. I'll show you something. This is like a little secret. Actually, I won't show it because it's secret. I've been working on a few different things with Zinc. So it's like it's not been properly shipped for something yet, but I'm like I use it as I make stuff. So when I'm making things, I kind of like improve the engine over time to do the things that I want it to do. What's been sort of nice is that over time I've found that like largely I don't need to add more stuff. I'm mostly working with the game code. I made this I called it like a Balaltro meets Mystery Dungeon game. Let's see if I can find it. Called Mystery Dungeon Hand. The source of this is online. Someone had a video of it. I don't know where it went. But it's like stuff. Basically, I use it in terms of like game jams and stuff. It's kind of like what I reach for to use things. Sorry, were there more questions?
Anyone? So how do you find managing the composition of complex scenes?
It's fine. So it's a little bit more explicit than something like Unity. So I'll show you where are we at here, like in code. So if you go to like the scene class, so you don't have to use scenes. You can like Actually, I'll show you this because I wanted to do this. I'll answer your question. I'm going to take a 2-minute digression. If you want to get started with Zinc, it's very easy. You can go to Zinc's template and you can click use this template, create a new repository. It'll clone everything for you. I'll call it like big demo. Okay. I'll create this repository. I will then come up here. I'm going to clone this. Git clone. And then I need to init the submodules here. Oops, I need to go into the place that I did. I'll take a moment because it's got to clone the Zinc source and the libraries.
While that compiles, I think my instinct would be to use something like tiled and then export that to a JSON and just build a scene, or at least like the background.
Yeah. So there's like, I could do a few talks. I'll show you that in one moment.
And everyone else, don't let me take up all the question time. If anyone else has any questions, please jump in.
Did he say what platforms it compiles and builds to, or is it just web?
You call out Windows, Mac, and web as the three.
Okay.
I would be shocked if it didn't compile to Linux, given Windows and Mac works, but I don't. Hello.
Okay, so I have to change my .NET version because I don't have 8 installed. This will run A. So that's how you get started with Zinc. Complex scene management stuff. So inside of scene itself, there's basically like a few different like callbacks. So it's more explicit in terms of management. So in terms of like asset management for scenes, there's like scene mounting and unmounting. So you can actually put multiple scenes up at once. And they can be layered on positions by depth. You can also load a scene. So there are like loading callbacks. So the scene can basically like if you want to like load assets before you display the scene, it will do all that loading stuff first before it then displays the scene. And then for arranging stuff, so tiled is like one thing. I'm also trying to do, this is like a longer term goal. People here might know LDTK. So this is like kind of like tiled on steroids. It emits like pure JSON. So it is like, what I'm trying to do is make Zinc be kind of like a glue between something like tiled. And then also I have my own, actually, can you even see it? Oh, no, I forgot I made it like this. I have this other tool that I make called Depot, which is basically like a static data editor for games, which could be another big talk maybe at some point. But what this does is it allows you to like basically author any static data for your game. And so the idea of Zinc is that like a lot of like data and editor and level design stuff is done external to the tool, but Zinc through things like what I was showing with like the asset loading with res, kind of like works with all that stuff natively and lets you like stitch it together, but does not itself give you like the ability to like build a level. So what I would target is that like I want to support LDTK's JSON output. So someone can like have LDTK over here, have Zinc running with hot reload, and they're just like working on stuff, save the file, and it's like updating over on Zinc's side. That's like the dream, and I wouldn't say it's a dream. Like it's very eminently possible. I just have other stuff going on in my life that makes it slower to work on.
Yeah, I like that. Why rebuild the wheel?
Yeah, I mean, I think also like, yeah, I think it's also like you can build your own level editor. Like you don't need to have me tell you how to build something. One of the goals with Zinc as well is like, I want every single Zinc user to use like the whole engine, right? Like if you're using like Godot or Unreal or Unity or something else, you can do like a lot of stuff. I'm trying to make Zinc be like just like full signal. Like ideally everything that it gives you is used by everybody, and there's like nothing superfluous on there. Everything else, like a level editor, is like, no, you just use tiled or use LDTK or build your own. Versus like me trying to say this is how you should build a level editor or something.
Okay, we'll have a couple minutes left. I have one last question that I'll shut up, and anyone else who wants to ask questions can go ahead. What kind of input device support is there?
So I'll pull this is the website for it right now. It's work in progress. So right now it's like keyboard mouse, similar to like low hanging fruit. My intention is to bring in SDL input, so it can like support controllers. All this infrastructure surrounding Zinc is set up to be really good at consuming header-only CLibs. SDL input is like one of these. So the idea is to basically just bring that over and then support gamepad and all that. Right now it does not do that though. It's just keyboard mouse.
Cool. All right. Yeah. Any questions from anyone else? All right, it looks like Stephen's typing something.
Hey, thanks for the Sokol libraries. I had never heard of them.
Of course.
Does Zinc deal with cleanup, so like unloading scenes and garbage collection, or is that all handled under Sokol?
That's all. Well, I guess it depends on what you're talking about. So like it will unload resources that are attached to scenes. So because a scene is basically just an entity, when any entity is like unloaded or destroyed, that traces through the hierarchy of entities. I also all the entity systems and stuff is all in managed C#, so there's no like native representation. So I think like Unity and I guess Unreal's all native, and like Godot, I believe all of them have their own sort of like native version of the object that has to also be cleaned up. It's like fully managed in Zinc. So it's basically you unload it and your side. If you keep a reference to it in the scene, then like that would be an issue. But if it's all attached to the scene and you unload the scene, the GC will just pick it up. Which has been my experience has been like fine enough, even with like 10,000 objects or something running around. That's just part of the actually in here, yeah, in the cleanup status here. I don't know where it's at. Yeah, so literally just like stages it for destroy, and then there is a what this does is it adds this destroy tag, and if I look at the references here, lifecycle systems. There's literally just a destruction system. So this destroys the ECS version of everything and then takes it all out. So it gets tagged for destroy, then it gets destroyed at the end of the frame. And that traces down the hierarchy. So like any children also get attached like that. Someone asked about UI elements. So that's a little bit of the secret thing. So, I mean, you can do UI with, shapes if you want to. I am in the process, or it's actually working. I have Zinc working with PanGUI, which is the UI library that is being done by the people that made Odin for Unity. So I got early access to that library, and I do have it up and running, and it's very good. So I've been sort of reticent to do anything with UI because I know PanGUI is coming out. So when PanGUI comes out officially in whatever way it does, that will be the UI library for Zinc. If you haven't seen PanGUI yet, it's very cool. I won't show you like the Zinc stuff, but I can show you like their library. If you look up PanGUI, yeah, it'll basically look like this. It's somewhere between like an immediate mode and a retain mode. There is also like ImGUI. I wouldn't say you should like use Dear ImGUI as your UI library, but you could. But I'm basically trying to not do more than this. And also when this is out, this also does things like text. So I might end up actually taking out my text system and just using the PanGUI one.
All right, I have one last question. How did you come up with the name Zinc?
Well, the engine actually used to be called Dinghy, like a boat. And I think I was telling people about like dinghy enough that it started to sound like dingy and it's like kind of hard to spell. And so I was like, I'm going to change the name. Zinc is sort of this like electronic, or it's not electronic. It's like a material substrate that allows things to be like conductive to each other, which felt kind of the spirit of what Zinc is trying to be as an engine. I also liked that where Z is on a keyboard, I can make easy parts of the Zinc API be like Z dot, which I just liked as a thing. So you can just like press Z with your ring finger and then do Z dot, and that should work.
Cool. Okay, we are out of time. Kyle, I want to thank you. This has been a great presentation. And thank you, Andrew, for recording too. I'm sure all of us are looking forward to reviewing the recording and picking up any things we missed.